Up where we left off in class today, where we were finding quadratic patterns. And we did 3 examples, and we started with something called the handshake problem. But then we made some steps. And the first step was to always check your differences. So if you check the first difference and it's constant, then you have a linear pattern. So for example, over here on the right hand side of the page, these numbers 7, 9, 11, and 13 are not constant. So we don't have a linear pattern. So step 2, then we would go to step 2 and see if the second difference, which is 2, 2, 2, is constant. So it is constant, which means we have a quadratic. And just to remind you of what it looks like if it's not quadratic, last night we only looked at simple problems where they all had a first difference that was constant. Like here the first difference is 1, and here the first difference is 4, and here the first difference is -2, and that number is the coefficient in the linear pattern. There's the -2, here's the 4, and the 1 is not shown, but it's there. So when you have a first difference that's constant, you write a linear pattern. But today we were in a more challenging problem set, and we are investigating when we don't have a first difference that's constant. And so we did 3 examples, example 1, 2, and 3. And even though we did example 3 in class, I thought it would help to go through it again for people that might be stuck. So like the example on the left, I'm going to take the first difference, and it goes up by 3, and then up by 7, and then up by 11. So the first difference is not constant, so it's not linear. This pattern is not linear. So now I'm going to check the second difference. And the second difference is up by 4 and up by 4. And also we talked about then this would have to go up by 4, which would make the next first difference 15, which would make the value 33. But since the second difference is constant, we know we have a quadratic because the second difference is constant. So we're going to go into single page mode here. Once you figure that out, you know you have a multiplying pattern. You don't really use these numbers again. So we're going to look for 2 numbers that multiply together. And so we are going to write a rule for a quadratic in factored form. And I did say it's very helpful, especially if you're trying to follow my work, but also for me to follow your work, and for you to follow your own work, to make straight vertical lines down so you can keep track of everything. So we're going to begin the process of finding that quadratic rule. And I'm just going to draw a line here. Oh, it's kind of crooked. Let's try again. There we go. Because everything in between, we are not going to use what's crossed out in yellow. So once you know you have a quadratic, you're looking for a multiplying pattern, which means we want to find 2 numbers that multiply to give the values. And you have to find a pattern. So there's lots of ways to get 18, like 1 and 18, and 2 and 9, and 3 and 6. And on the other graphs, we started from the left and worked to the right. But since there's a negative and a 0, sometimes it's easier to start from the right and work to the left. So the ways to get 7, I can think of really just 1 times 7. So looking at that, I want to try to use a pattern. So what we found was we had to try them. So if I tried 2 times 9 and then did 1 times 7, the pattern would go from 9 to 7 to 5, and we would have to see if it makes a pattern and if I can make the term 0. So going from 2 to 1, the pattern would say 0, and 0 times 5 is 0. So following in this pattern, 9, 7, 5, 3, and following the 2, 1, 0, -1, I've created a multiplying pattern. Because the product of those two numbers, like -1 times -3, gives you the value. And then the rule, when the parentheses are next to each other, it's a product. So it turns out that this I didn't need, that one didn't help, and that one didn't help. So what we did in class was we went from this one number to the next, and I'm looking at the easier one first, to go to 3 to 5, and 5 to 7, and 7 to 9. It's a constant difference of 2. And so in each one of those parentheses, I'm going to write a linear pattern, because when you factor a quadratic, you have 2 linear patterns. So this is 2n. And then I have to go all the way up to the term and ask myself, 2 times 4 is equal to 8. But I need to get this value of 9 up there. So I have to add 1. So let's check to see if I did that right with another value. 2 times 3 plus 1 is 6 plus 1, which is 7, and that's this value right here, the 7. So that rule works. Just one more time. 2 times 2 plus 1 is 5, and right here, that 5 is what I'm going for. So that works. So that's my rule for the second term. Now for the first part of the numbers, how do I get from -1 to 0 to +1 to 2? Well, I increase by 1 each time. So my rule is going to be 1n. That's a little hard to read. Or just n. And then I do the same thing up here. I'm going to say 1 times 4. So I pick any term value, and I get 4. But I have to look all the way down here, and I need a 2. So I'm guessing it's going to be n minus 2. But I'm going to check with the 3. So 1 times 3 is 3, and if I subtract 2, I get this 1. So it works. And then you could check again if you want to. 1 times 1 is 1, subtract 2, and you get -1, and it works. So that's my rule. I have it in a different order, but that's the rule. And then to put in 20, 20 times 2, 2 times 20 plus 1, that's 18 times 41. And that should be the missing value. You could do that by hand or with a calculator. 18 times 41. Guess I didn't put the answer in. Should be 1681. Let's double check it. 18 times 41. Ah, there we go. Oh, I guess I didn't do a very good job of estimating first. There we go. So, but really what you could be checking is like maybe 5. Because if I put 5 into the rule, I get 5 take away 2 times 10 plus 1, which would be 3 times 11, and I get the 33. So that's what we did in class. It's a lot. We're going to finish with the handshake problem. This is a little bit harder. So when you have 2 primes in a row, you won't be able to find a multiplying pattern. But we're still going to go through the process of first differences and look at these numbers that we built in class. We already came up with these numbers for the handshake problem. And we already figured out that the first difference was not constant. That was our warm-up. So the second difference is constant. So I should write that over here. First, not constant. But the second is constant. So that means we have a quadratic because these go up by 1. So the process remains the same, but this is trickier because when you look at some patterns, you can't find a multiplying pattern right away. So you can use a technique that'll help you do that. So because there's 2 primes in a row, if I try to get a multiplying pattern, say for 1, I only could do 1 times 1 and 3, 1 times 3. So there's no way, that's not going to help me because the pattern would be 1 times 6, and I'm stuck with the exact same numbers. So I'm not going to be able to find a rule. So the trick is try doubling. We know it's quadratic, so we know we have 2 linear factors multiplied together. But these numbers up here are hard to work with, so I'm going to just double. 0 doubled is 0, 1 doubled is 2, 3 doubled is 6, 6 doubled is 12, 10 doubled is 20. And I'm going to look for a multiplying pattern. But if I double there, I have twice what I want, so I'm going to cut my answer in half. But then I'm going to just continue the process and look for a multiplying pattern. 1 times 2, 2 times 3, 3 times 4. There's a nice pattern. 4 times 5. So this could be 0 times 1, or you can just ignore the 0 altogether because we have enough other things to work with. So to get from 1 to 2 to 3 to 4, I need to go up by 1. So it's 1n. And then I need to go up here. 1 times 4, for example, is 4. But I really need to get a 3. So I'm trying to get this number from the term. Let's check. From the term 5, 1 times 5 is 5, but I really need to get a 4, so I have to subtract 1. Now, if we look at the second term, we get from 1 to 2 to 3 to 4 to 5. We're still going up by 1. So we have a 1 here. But now, when we work with the term 5, 1 times 5 is 5, and I already have a 5, so I don't need to adjust it. 1 times 4 is 4, and I already have a 4. So my rule should be what I have written there. And it's written in reverse order, but that's the same. And we figured that out by looking at pictures earlier. So for the 30, we also figured out 30 times 29 divided by 2 would be our nth term. And 30 times 29 divided by 2, 435. It's the number of handshakes. All right, that's enough to get you through your review worksheet. We'll talk more about it in class.